Hello, respected sir and ma'am. Myself, Nitin Vishwakarma. I am from third year Computer Department of Siagat College of Engineering. I would like to introduce you to my team DedSec members.
Hello there, myself Yash. I am from third year computer department.
Hello, I'm Siddhi Vadke from third year computer department.
Hello, myself Harshita Devgade and I'm from third year computer department.
Hello, my name is Anas Faz, third year from computer department.
Hello there. My name is Yash Kumar Wankhede, third year Information Technology Department.
So, as you have got familiar with the team members, let me begin by sharing you with our ministry for the problem statement. That is the Ministry of Power. And our PS ID is SIH1381, which is associated to the problem statement analysis and identification of malicious mobile applications. So now Suyash will continue with the key features that our tool provides.
Welcome to the actual presentation. Let me begin with the features that are included in our tool that make it reliable and unique. You may wonder, what makes our tool unique? What does it have to offer that the currently available tools don't? So let me share with you the key features that are packed inside our tool. So the first one, that is the attacker backtracking. It can be used to extract the listeners, which you may call the attacker's IP and port, through which the attacker maintains connectivity with the malware. Hence, it might be possible to identify who the attacker or hacker is. Nextly, we have another great feature that can scan the obfuscated application by firstly decrypting and then decompiling it. That would make it easier to identify the application is malicious. Further along, our team leader Nitin Vishwakarma will join in to explain the remaining features.
Thanks for that, Suyash. Now I will go ahead with the features that our tool has. That is URL analysis with firewall, which refers to the process of examining the URLs that applications are trying to access in order to identify potentially malicious websites. This will reduce the risk of malware infections, data breaches, and other security incidents. The second feature I would like to introduce is application behavior analysis, which is the process of closely monitoring how a software application operates to detect any unusual malicious activities. This involves examining application interaction with system, network, and data to identify signs of compromise. Now I will hand over rest of the features to Siddhi.
The fifth feature is network based detection, which is done statically or dynamically. These ways include IP or DNS blacklisting, string matching, and use of machine learning algorithms. Using these ways, we analyze the specific pattern for the generated traffic in all the applications in our device and find the deviations. Based on this analysis, we update the patches in specific time intervals. These patterns are based on total concurrent connections and the send or receive TCP or UDP packets on a device. The sixth and the last feature is auto reporting system. This system includes automated threat detection and response. Automated reports about the working of our tool and malicious attacks are generated and sent to the developer for further analysis, improvements, and appropriate measures against the threat, such as reporting to the cyber cell using software APIs. Now, Suyash will explain the flowchart.
So I'm back again to share with you the flow chart. Basically, it will consist of two phases. The first one, that is analysis phase, will consist of checking unknown applications, dividing them into normal, obfuscated, and bound applications. Then the obfuscated applications will be decrypted, whereas the bound applications will be separated and then decompiled. Then comes the identification phase, where our previously analyzed applications will be cross-checked with the pre-built malware detection libraries for any suspicious backdoors. If and when a malicious application is found, a particular user will be alerted and the application will be reported as malware. So that's it for flowchart. Now Harshita will continue with the technology stack.
Now comes the technology stack. Here we are going to make use of Windows and Linux because Windows limits certain features which can then be fulfilled by Kali Linux environment. Since we are building an antivirus tool for Android, we are using languages Java and Kotlin. And for ensuring compatibility across various devices, we are using Flutter for cross-platform development. Now, our backend is the engine that powers our analysis. So, for the server, we are making use of Python with Django for real-time data processing, and we rely on the Firebase real-time database that ensures the latest data for analysis. The last comes threat intelligence integration. Crucial part of Stack is integration with threat intelligence provider because this enables us to conduct static and dynamic analysis, monitor network traffic, and detect anomalies using machine learning models. Now, the use cases will be explained by Anuswar.
But as Harshita assisted us with technological stack, you will be familiar with tools used. So stepping forward, I'll elaborate the use case for our tool. Our tool provides various features. Some basic features like threat detection for personal devices, where individual can use app to monitor any suspicious network activities like unauthorized connection or data transfer. Another unique features which is enterprise mobile security, where business or IT company can deploy this tool to the employee device to ensure security of corporate data. Now the other use case will be carry on by Yash Kumar Vankade.
Okay, so the next point is safe browsing. Safe browsing basically refers to using of internet in a secure and responsible manner to protect ourselves from online threats and malicious activities. With our tool, it is possible to check the vulnerability of URLs which we receive through mails and messages. This tool also helps safeguard personal information, privacy, and digital devices from virus, malware, and phishing scams. Coming to the next point, we got parental control. Parental control refers to the set of tools and measures that parents carry out to manage and monitor their children's online activities. Parents can install our tool on their children's devices, which will help them to track suspicious activities and ensure a safe and secure atmosphere for their child. Now, I would like to call Anas Fez to explain the dependencies.
Our tool is heavily dependent on certain factor like API, where a disruption in API service can impact the tool's functionality. Another dependency is the effectiveness of the app relies on the availability and quality of open source threat intelligence field. Now again I would like to ask Yash to accompany us and explain the further dependencies.
So now the next point is machine learning model. Accuracy of the model is of utmost importance as important features are dependent on it. In this, we provide the model with two sets, that is, training set and testing set. In training set, we ourselves give threat with its information for the detection by model. And in testing set, we just provide some raw information and check if the model can detect it. Now, the next is security testing. The whole process revolves around this security. We must check and recheck our tool for any flaws, as any of the smallest crack in the door will allow the hacker to breach into the system. Therefore, security testing plays an important role. Now, I would like to call my friend Harshita to explain the next two dependencies.
So, the next dependency is access specifications. So, our tool may require unusual permission that the user may find compromising. For example, as call dialer require access to contacts, our tool will significantly require some special permissions to be able to access and monitor the malware. The next one is unrestricted internet access. There is no restriction over the internet access to keep the app updated with newer patches and latest features without any limitation. Now, in order to conclude our presentation, I would request Siddhi to give the overview of this presentation.
Finally, I would like to give an overall gist of all the points that were put forth in this presentation. The features of a tool are attacker backtracking, decryption of obfuscated applications, URL analysis with firewall, application behavior analysis, network monitoring, and auto reporting system. The tech stack includes Windows, Kali Linux, Java or Kotlin, Flutter, Python with Flask, Firebase real-time database, and threat intelligence integration. The use cases include threat detection for personal devices, enterprise mobile security, safe browsing, and parental control. And lastly, the dependencies include open source threat intelligence feed, API integration, machine learning models, security testing, access specifications, and unrestricted internet access. And hereby we conclude our presentation. Thank you.